Hello everyone, this is Mr. Harper continuing our discussion on the skeletal system, and today I want to talk to you about the development of bone. Now, we think of bones as, well, they're just bones, they're just there and they're not doing anything, but actually there's a whole lot going on in bones. Bones are living tissue and they're constantly being changed as we go through our lives. So let's talk about this a little bit. So, got to go back one screen. So the skeleton of an embryo is made entirely of cartilage. Embryo, before the baby is even born, starts as an embryo, develops into a fetus, and then finally born this baby. It's made entirely of a soft tissue called cartilage. Now, there's a couple of kinds of cartilage in your body. Some cartilage is found in bones, joints, in the joint between bones, and it's really slippery to help the bones move smoothly. But that's not the kind of cartilage I'm talking about. This is a cartilage that is actually part of the bone. And the skeleton starts out as cartilage, and the one advantage of this is cartilage is flexible, and it'll bend a little bit. It's easier for an unborn baby to go through a birth canal that's very, very tight if the bone structure is mostly cartilage because there's some bend there. So it starts out as cartilage, and it's a strong connective tissue. It supports the body, but like I said, it's softer. It's more flexible than bone. And cartilage, at birth, there's still a lot of cartilage in a baby's skeleton. You think of like a soft spot on the top of the head of a baby. That soft spot is areas where the bone has not grown together yet, and that's all cartilage, and that's going to gradually grow and become bone as that cartilage is replaced by bones. So there are cells, bone cells called osteoblasts, and their job is to build bone. And they take calcium and phosphorus from your diet, and they put that calcium and phosphorus into the cartilage and turn it to bone. And this process of cartilage being turned into bone is called ossification. It occurs throughout your life. Now, there's also a cell called an osteoclast that breaks down damaged weak bone or old bone, because your bone is constantly being repaired and remade. It's not like your bone is made and then it just stops. So there's always cartilage being put into bone, there's always calcium and phosphorus being put into bone to turn that into strong bone, and then it's also being taken out. The bone is like a depository or a reservoir of calcium and phosphorus that your body needs. When you eat and you have a whole lot of calcium, your body is busy putting that calcium and that phosphorus into the bone structure. And then later on, if you don't have enough of it in your diet, your body will take and break down some of that bone, the osteoclast cells will, and take that cartilage and that phosphorus out, and it makes the bone a tiny bit weaker. But over time, your body's constantly putting that calcium and phosphorus back in with the osteoblasts. So as long as the process of building up bone and tearing down bone occur at the same rate, your bones stay the same and the structure is strong. So how does a bone grow, and actually how does someone actually get taller? At the ends of long bones, there's an area called the epiphyseal plate or growth plates, either end of the bone. And cartilage in that bone grows from when a child is young, and as that cartilage grows, the bone gets longer, and then gradually that cartilage is turned into bone structure itself in the process we just described. And by early adulthood, cartilage in that growth plate has been entirely replaced by bone. That whole bone is ossified, and the bone growth stops. So look at this X-ray picture. Right here, between these two bones of the radius and two bones of the ulna, well, two pieces of the ulna, I shouldn't say two bones because it's all one bone here, but you see this dark area. This dark area is an area that shows the cartilage. So this is what's called an open growth plate, because you can still see through that bone with an X-ray, and that means that this is not hard bone yet. If it was all white, then that growth plate would be closed. So this is showing someone that can grow yet. That bone is going to grow longer because there's cartilage in this growth plate. Once the bone is all totally solid, there's no little gap in between it, then we call that growth plate closed, and that person will not grow anymore. So a doctor can, if you break a bone a child breaks a bone and the x-ray happens to show the growth plate anyway, the doctor can examine it and say, yes, this person's going to grow a lot yet, or not. Or you're going to be really tall perhaps because you have a really large growth plate, or not. So quickly, what we've talked about today, we've talked about the development of bone. Bone is constantly being built up and torn down. Our skeleton starts as a cartilage and then is gradually turned to bone after we're born. And there are cells called osteoblasts. Their purpose is to build cartilage into bone by taking and putting in minerals into that bone, calcium and phosphorus. It turns that cartilage into bone. And then there are cells called osteoclasts that are constantly breaking it down. And bone needs to be broken down and repaired over our entire lifespan. So as long as the bone is broken down at the same rate that it's built up, then your bones are going to remain strong and healthy.